Hello, you are welcome once again to my YouTube channel. Today I will be discussing and showing you how to use a 555 timer to flash a LED. The 555 timer can operate in three different modes. Number one, it works in a bistable mode, it works in a monostable mode, and it can also work in a astable mode. So when it works in a stable mode, it goes on and comes off at an intermittent frequency, such that the time of on and the time of offing are programmed by the values of our resistors here and the capacitor here. That means in today's video, the most important part is the fact that we are studying it in an unstable mode, and in an unstable mode, R1, R2, and C1 are very, very important in determining the time it will take for it to remain on and the time it will take for it to go low. So before I go ahead about that once more, let me show you the components. As you can see them already here. We have the battery, 9-volt battery, which will be here. I will place the battery here, and then we have the 555 timer itself. This is it. Now, as you can see, this timer here, it has 4 pins on each side. So 4 pins on each side, making 8 pins altogether. Now, looking at these pins, you will be wondering, where is pin number 1? Where is pin number 2? Look very closely. The technique I use to identify this pin is that number 1 is usually by the left, close to the notch. You see that there is a notch? The notch on towards this area, yeah, this notch. So the first pin by the left is number 1. So number 1 followed by number 2, number 3, number 4, then number 5 starts from here. This is number 5, number 6, number 7, then number 8. So it spans from all the way from number 1. Here is number 1 and here is number 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, that's all about that, about the 555 timer. Then we have 5. This is a 100 kilo ohm resistor, 100 kilo ohm, 100 kilo ohm. I will be using it I can use it to replace the 500 kilo ohm here. About this 500 kilo ohm, I will talk very briefly because that's the essence of this potentiometer also. The reason why I brought this potential to show you that beyond just putting a fixed resistor here, we can decide potentiometer. I will talk about that also in a few minutes. So the next component is the capacitor. I will be using a 10 microfarad capacitor, 10 microfarad, then 1 kilo ohm resistors, two 1 kilo ohm resistors, which will be here, and the other one will be here. Now, this is a battery connector that I will use to connect the battery to this circuit here. Now, if you look at the remaining ones, we have the LED as well as the buzzer. There is a buzzer. It buzzes, it makes a sound, beeping sound like this. I'm sure you can hear it. It's sounding intermittently. That's the timer at work there. So depending on whatsoever we want to put as our load, we can decide to use a buzzer, just like you've heard the sound of a buzzing alarm. We can just to use a buzzer or a LED. Now, if you put a LED here, you will see it blink. It will flash depending on the time we have set here. It will flash or blinks. But if we decide not to put a buzzer, if what we want is the alarm that just sounded some seconds ago, we could use this buzzer. But then this buzzer will not be able to the signal, the output here will not be strong enough to power this buzzer. So there will be a need for an extension. We need to impute this signal into the base of a BJT transistor. As I was showing you earlier, now I've decided to replace the LED with a buzzer. So I will just talk briefly on how to drive the buzzer. So I call it a time controlled buzzer. Once again, all the components are the same. except for the buzzer and the BJT I just introduced. The 1 kilo ohm resistor is here, and then I change this 500k initial 500k to 100 kilo ohm. The capacitor is 10 microfarad. Now, the output usually would have come from pin 3. As it comes out, initially it was 1 kilo ohm and it's still remaining 1 kilo ohm. So the current from here will be so minimal, the signal will be so weak that it will not be able to power this buzzer if I had put it here directly. So for it to be driven by a larger current, I needed to introduce this NPN transistor BC547. The collector, the emitter, and the base are all indicated. So this is a 100 ohm resistor to keep the buzzer from being damaged by the battery. Should there be any necessity for that? So the battery both powers the system, the timer and the buzzer. So when the current flows in this direction, it powers this, and then the base of this transistor is triggered by the output of this whole system. So this output will be intermittent. The time of its high and its low are determined by this formula, which corresponds to the value of R1, R2, and C1. So when you input this here, you will get the high time and the low time. So when it is high, the transistor will open and will close. When it closes, current will flow through. So the buzzer will buzz. And then when the time has gone, when the time has come for it to go low, it will go low. The transistor will open. When it opens, the whole system will go off. So it will continue like that intermittently as this capacitor is charging and discharging, charging and discharging. Then the time will also be the time it takes for it to charge and discharge will correspond to the high and low of this transistor. So that will determine the beeping of the sound. Let me give you an example of what I've been explaining. Alright, here is a transistor, the BJT transistor, already in the circuit. The 100 ohm resistor is there. Then the buzzer is here. Then we have the battery, and then we have the capacitor 10 microfarad. The 5 timer itself is here. Then the 100 kilo ohm resistor and the 1 kilo ohm resistor. So when I connect the wire now, that's it. And you hear the buzzing. So it's corresponding to the time it's taking the capacitor to charge and discharge. So that's just the basic principle of 5 timer in an unstable mode to build and cause a buzzer to buzz intermittently. Thank you for watching.